Alright, so in this problem, I have x to the power 4 is equal to 4. So to solve this, I'm going to first start by subtracting 4 on both sides. So then these two cancel out, and I get x to the power 4 minus 4 is equal to 0. Now, I'm going to rewrite 4 here as 2 squared. So now I have x to the power 4 minus 2 squared is equal to 0. And I'm going to write x to the power 4 as x to the power of 2 times 2. So I have x to the power of 2 times 2 minus 2 squared is equal to 0. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 2 times 2, I can rewrite that as x to the power of 2 to the power of 2 minus 2 squared is equal to 0. Now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is x squared and b is 2. So I have x squared plus 2 times x squared minus 2 is equal to 0. Now, this gives me two equations. I get x squared plus 2 is equal to 0, and I also get x squared minus 2 is equal to 0. So to start, for x squared plus 2 equals 0, I'm going to subtract 2 on both sides. So then these two cancel out, and I'm left with x squared is equal to 0 minus 2, which is negative 2. Now I'm going to take the square root on both sides. So I have the square root of x squared is equal to the square root of negative 2. Square root of x squared is obviously x, so I have x is equal to positive or negative square root of negative 2. And the square root of negative 2, I can rewrite this as the square root of 2 times the square root of negative 1. And if you guys already didn't know, the square root of negative 1 is equal to the imaginary number I. So I have x is equal to positive or negative the square root of 2 I. Now for this one, I have x squared minus 2 equals 0. So this time I'm going to add 2 on both sides. These two cancel out. And I get x squared is equal to 2. And now I'm going to take the square root on both sides. Square root of x squared is x. So I get x is equal to positive or negative square root of 2. So now to check, that is actually, those are our 4 solutions to this problem. Alright, so in this problem, I have x to the power of 21 plus x to the power of 14 is equal to 36. So I'm first going to rewrite this as x to the power of 7 times 3 plus x to the power of 7 times 2 is equal to 36. Now, I'm going to put this as x to the power of 7 to the power of 3 plus x to the power of 7 to the power of 2 is equal to 36. Now I can let x to the power of 7 equal to the variable y. So now I have y to the power of 3 plus y squared is equal to 36. Now if I subtract 36 on both sides, these two cancel out, and I get y to the power of 3 plus y squared minus 36 is equal to 0. Now negative 36, I can rewrite this as negative 27 minus 9. And now I can rewrite this as y to the power of 3 minus 3 to the power of 3 plus y squared minus 3 squared is equal to 0. So if I have something in the form a to the power of 3 minus b to the power of 3, this is equal to a minus b times a squared plus ab plus b squared. And if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, I can rewrite y to the power of 3 minus 3 to the power of 3 as y minus 3 times y squared plus 3 squared plus 3y, plus I can rewrite y squared minus 3 squared as y plus 3 times y minus 3, and this is equal to 0. Now if I factor out y minus 3, I get y minus 3 times y squared plus 9 plus 3y plus y plus 3. This is equal to 0. And this is simplifies into y minus 3 times y squared plus 4y plus 12 is equal to 0. So this gives me two equations. Y minus 3 is equal to 0, which means y equals 3. This is one solution. And y squared plus 4y plus 12 is equal to 0. So to solve this, we have to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac over 2a. And I'm not going to waste your time actually plugging them in, but if you do, you end up getting that it's less than 0, so this won't work out. So y equals 3 is my only solution to this equation. Now remember how we let x to the power of 7 equal y. So now I have x to the power of 7 equal 3, meaning x is equal to the 7th root of 3. Alright, so in this problem, I have x to the power of 6 minus x to the power of 3 is equal to 2. So I'm going to first start by subtracting 2 on both sides. So now I have x to the power of 6 minus x to the power of 3 minus 2 is equal to 0. Now I'm going to rewrite x to the power of 6 as x to the power of 3 squared. Now I have this minus x to the power of 3 minus 2 is equal to 0. Now I'm going to let x to the power of 3 equal to the variable y. So now if I substitute in x to the power of 3 for y, or sorry, y for x to the power of 3, I get y squared minus y minus 2 is equal to 0. So now I'm going to factor this by rewriting this as y squared minus 2y plus y minus 2 is equal to 0. Now I'm going to factor by grouping, so I have y times y minus 2 plus 1 times y minus 2 is equal to 0. So now if I factor out y minus 2, I get y minus 2 times y plus 1 is equal to 0. So this gives me two equations. Y minus 2 is equal to 0 and y plus 1 is equal to 0. For y minus 2 equals 0, y equals 2, and for y plus 1 equals 0, y equals negative 1. Now remember how we let x to the power of 3 equal y. So now I have x to the power of 3 is equal to 2, and x to the power of 3 is equal to negative 1. So for x to the power of 3 equals 2, I can simply take the cube root on both sides. So now I have x is equal to the cube root of 2. And for x to the power of 3 equals negative 1, again, I'm going to take the cube root on both sides, so I get x is equal to the cube root of negative 1, and the cube root of negative 1 is simply negative 1. So I have x is equal to negative 1. So these are my two solutions to this problem. Alright, so in this video, I'm going to solve the problem 2 to the power of 25 minus 1. So, to first start, I'm going to rewrite 2 to the power of 25 as 2 to the power of 24 plus 1. And then we have our minus 1 at the end. And the reason I'm doing this, and rewriting 25 as 24 plus 1, is so now I can use the property a to the power of m plus n is equal to a to the power of m times a to the power of n. So 2 to the power of 24 plus 1 is going to equal 2 to the power of 24 times 2 to the power of 1 minus 1. Now basically our goal throughout this video is to change our values to be as small as possible, so then at the end we can do whatever we need to do with them to get our final result. So 2 to the power of 24, how do we simplify this and make it even smaller? I can rewrite this as 2 to the power of 12 times 2. And another property of exponents is that if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 12 times 2 is going to equal 2 to the power of 12 to the power of 2. And I have this times 2 minus 1. So now I'm actually going to plug in the actual value of 2 to the power of 12, because 2 to the power of 12 is small enough where we know the exact value of it. So if you guys don't know what 2 to the power of 12 is, well, 2 to the power of 10, you should always remember this as 1024. So 2 to the power of 11 is going to be double of 1024, which is 2048, and 2 to the power of 12, which is the value we're looking for, is going to be double of 2048, which is 4096. So now I get 4096 squared times 2 minus 1. And now this is equal to, I'm going to simplify this, 4000 plus 96 squared times 2 minus 1. And the reason I'm doing this is because 4096 squared is really hard to calculate by itself. So if we change it to 4000 plus 96 squared, I can use the property a plus b squared is equal to a squared plus 2ab plus b squared. So in this case, a is 4000 and b is 96. So this turns into 4000 squared plus 2 times 4000 times 96 plus 96 squared. And I have all of this minus 1. Oh, sorry, all of this times 2 minus 1. Now, 4000 squared is equal to 16 million. 2 times 4000 is 8000, and 8000 times 96 is equal to 768,000. And now I have this plus 96 squared, which is equal to 9,216. And all of this I have times 2 minus 1. So now I'm going to add all these up. So if I add all of these up in the parentheses, I get 16,777,216. So now I have this times 2 minus 1. So if I multiply this by 2, I get 33,554,432. And I have this minus 1, which is equal to 33,554,431. So this is my answer to this problem.